Okay, so today we are going to discuss about the solubility here. Okay, so what is the meaning of solubility? As I have already discussed with you, the maximum number of moles of solute that can be dissolved in a particular volume of solvent. Okay, and it forms the saturated solution. And I guess I already told you what is the saturated solution. So when no more solute in the dissolvent, right? I guess I
Mm-hmm.
told you, I gave you example of a jalebi, right? Inside the
Mm-hmm.
jalebi there is a chashni. You can say like sugar solution, so
Mm-hmm.
that is a saturated solution. You can't dissolve
Anymore.
solute, yeah. So it means if I talk about a solubility here, so what is the meaning of solubility? The maximum number of moles of solute, and I guess I told you how to find out the moles. So given mass divided by molar mass, right? So
Mm-hmm.
that is how you can find out the number of moles. So solute that can be dissolved in a given volume of solvent, and then it will form, yes, any guesses, then it will
And
form
then no form of precipitate.
no, no, not precipitate, not precipitate. Like if there is
Like
a
the,
sugar solution, so it is not a precipitate.
oh
You can say it's a saturated solution, right? So to
oh
form a
yes.
saturated solution, because if it form a precipitate, then it would be a precipitation reaction, and we are not
Yes.
here for making precipitation reaction.
Mm-hmm.
Okay,
I just thought that. Oh, sorry. Never mind.
so okay, so saturated solution here, but remember it is happening at a particular temperature, and this is called the solubility. Okay,
Mm-hmm.
so there are so many factors on which solubility depends upon. So if I talk about the fact, yes, any guesses on which solubility depends? There are certain factor on which the solubility depends. Any guesses?
Temperature and pressure.
Okay, very fine. Okay, so the most important factor I can take temperature. Okay, so whenever we provide the heat to any solution, the solubility increases or decreases?
Whenever you provide heat, the solubility increases.
Yes. So do you know whenever you make a tea, so when we put a sugar in it and when we are heating it, so sugar automatically dissolve in it, right? So
Mm-hmm.
why? Because we are increasing the temperature. So if we are increasing the temperature, more is the solubility of solute in the solvent. Now, and this, so it means more the temperature, more is the solubility, right?
Mm-hmm.
Okay. Second thing, you said pressure. Yes, we can also take pressure, but if I take more technical word, so okay, can I say that a lattice enthalpy? Because I'm
Yes.
talking about the solubility of salt. So lattice enthalpy. Okay. So if more is the lattice enthalpy, so what do you think? More is the solubility or less is the solubility?
More.
No. See, what is the lattice enthalpy? Suppose if there is a Na plus and if there is a NaCl, right? Minus, so that is a salt, right? So if
Yes.
they are attached tightly, if Na plus and Cl minus they are attached tightly, so will it get dissolved in the solution? Will it get dissolved
No.
in the solvent? No. So that is the lattice enthalpy, like amount of energy required to break the Na and Cl.
Mm-hmm.
Okay, so that is a lattice. So if they have
Yes.
a high lattice means they have a strong bond. So if they have a strong bond, so they won't be able to dissolve in the solvent. So it
Mm-hmm.
means if more is the lattice enthalpy, then solubility would be less, right?
Okay.
So it's
Mm-hmm.
a direct relation or indirect relation?
It's inner relation.
Yes, it's a inverse relation. So if like, so here, so NaCl have a high enthalpy or less enthalpy?
It usually has a low enthalpy.
Yes, so NaC, because whenever we put NaCl into any kind of solvent, especially water, so it easily dissolve in it, right? So it
Mm-hmm.
means it has low lattice enthalpy. That's why it has high solubility, isn't it? And now it's a solvation enthalpy. And what is the meaning of solvation enthalpy? Okay, so when we are adding, suppose let's take an example of that NaCl. So when you are adding this NaCl into any kind of liquid, so this NaCl trying to make bond with the liquid also, yes or no?
Yes.
You can see that liquid. So that
Mm-hmm.
Na and Cl, it is getting separated, and now it is going to form bond with the solvent. So whenever there is any particular solvent, so this solvent try to make bond with that particular salt. So that is called solvation enthalpy. It means the amount of energy release when this NaCl and when any kind of solid trying to make bond with the solvent. So that is the solvation enthalpy. So it means, can I say, so if more is the solvation enthalpy, it means more is the solubility, because it has
Mhm.
already make bond with the solvent. And if they are making bond with the solvent, so it means it is already getting dissolved in it, right? So it means
Right.
more is the solubility. Okay. So and some people also, so can you tell us about hydration enthalpy? Yes, solvation and hydration enthalpy is same, only difference is when that solvent is water. When that solvent is water, then it become hydration enthalpy. But if there is any particular solvent except the water, then you will call it as solvation enthalpy. Okay.
Mhm.
So
Okay.
whenever solvent is water, then it is better to say hydration enthalpy. Okay, if I say there is the solvent is benzene and it is forming bond with the NaCl, so just tell me, it is a solvation enthalpy or it would be a hydration enthalpy? What do you think?
Salvation.
Yes, solvation. Why? Because it is not water. Okay.
Yes.
So
Mhm.
for any kind of salt, yeah, for salt to be dissolved, lattice enthalpy should be less than the solvation enthalpy, right? Because lattice enthalpy means they are strongly attached. So
Yes.
if lattice enthalpy would be high, so it is not going to form bond with the solvent. So it means
Mhm.
if I say for a salt to be dissolved, so lattice enthalpy should be higher or solvation enthalpy should be higher.
Salvation entry should be higher for salt to
Yes.
dissolve.
Very good. So it means for that your solvation enthalpy should be higher and lattice enthalpy should be low. Okay, fine that. Now after that, if I say like they I am dividing these kind of solubility into the three categories. Okay, so here remember, here whenever I am talking about the solubility, so its simply meaning is molarity. Okay, the
Mhm.
molarity solubility you can take it as also molarity, solubility. Okay, so solubility and molarity you can take, like this is how we can find out the solubility. So now here suppose if your solubility is greater than zero point 0.1 molar solution, or you can say zero point 0.1 molar. Okay, so if your solubility is coming which is greater than zero point 0.1 molar, then of course that salt should be soluble, and you can say that is a soluble salt. Okay, so suppose if I am saying that there is a any copper sulfate and I am putting it into particular solvent. So if for that solvent or for that solution there is a molarity is 2 molar, suppose. So it means it is greater than zero point 0.1 molar, right? So it means
Mhm.
that salt is completely soluble and it is a soluble salt. Okay, but if I say if solubility is less than the zero point 0.1, then if your solubility is less than zero point 0.1 molar, then it is not going to get dissolved, or you can say a very sparingly soluble salt it would be. Okay, so you can say kind of insoluble, it may be insoluble or very sparingly soluble.
Yes.
So
Mhm.
sparingly. Okay, got it.
Got it.
Okay, now okay, so actually now fine then. After that, so whenever I talk about the sparingly soluble salt, so soluble salt we already know that, right? So the all those ionic salt which have the solubility are less than zero point zero 0.01 molarity, so they are sparingly soluble also, right? Like suppose
Mhm.
if I say if you have a salt and whose molarity whose solubility is zero point zero 0.01 molar, so just tell me, would it be soluble or insoluble?
Insoluble.
Yeah, and you can also say sparingly soluble salt, right?
Yes.
Isn't it? So if I
Mhm.
take example for that, so you should know AgCl, okay, silver
Mhm.
chloride,
Sir chloride.
and you can
Yeah.
take also barium sulfate. So these are the
Mhm.
salt which are sparingly soluble. Okay, so for a sparingly soluble salt, remember the ionization in the aqueous solution is very small. They are not going to give the, like they are not easily broken down, right?
Mm-hmm.
Okay. So now here I am going to discuss about a very important portion, which is solubility product. Okay. So we have a one factor, and that factor we are going to study about the solubility product. What is the meaning of that? Okay, it's like it's a product of the concentration of the ion in the concentrated solution of the salt. Suppose if you have a NaCl, then if you are putting that salt into any kind of liquid, so it is going to break into Na plus and Cl minus, right? Or you can say it is going to be broken into Na plus and Cl minus. Am I right?
Mm-hmm. Yes.
Okay, so that is how we can find out the solubility product by considering, by taking the product of concentration of that ions. Okay, I'm going to tell you how can we find out that. See, it is the product of concentration of ions in a saturated solution. What is the meaning of saturated solution? Yes, George.
What means that the maximum number of moles has been dissolved in the solvent?
Okay, and if I ask you what is molarity, I guess I told you.
Mm-hmm.
Yeah, can you tell me?
Oh, so molarity is basically the amount solid that's going to be inside the solvents.
Not accurate definition. Can we say that the number of moles of solute present in 1 liter solution?
Mm-hmm.
I guess I told you this. I guess,
Yeah.
and I guess you forgot that. Okay, so solubility product is what? The product of concentration of the ions in a saturated solution of any kind of salt at a given temperature. So now, suppose if you have any kind of salt, suppose let's take an example, AX and BX, or you can say like BY. Okay, it is a salt. So if it is in equilibrium, so it is going to get dissociated, right? So
Mm-hmm.
after dissociation, it will become something like that. XA Y plus, and it will form YB X minus. Okay. So this is
Mm-hmm.
how a salt is going to broken down. See, many people say, so what is that? I'm not going to understand. See, suppose if you have a barium sulfate. Okay, so it is going to be broken down like that, right? Ba, sulfate has 2 minus charge, right? So Ba
Mm-hmm.
2 plus and sulfate 2 minus, am I right?
Yes.
So this is the charge. Okay, so that's why I wrote here x y plus and y x minus. So this is
Mm-hmm.
the charge. Okay, and if I say NaCl, so it is going to Na plus and Cl minus, isn't it?
Yes.
Okay, and suppose if I say AlCl3. So if I
Mm-hmm.
say AlCl3, so can we say that AlCl3, see, chlorine has a minus one charge. So of course
Yes.
it is going to be like Al 3 plus, right? So can you
Mm-hmm.
just see? I told you By and it is
Yeah.
Cl3. So so there is a charge of Y plus. So can I say Y is what? 3 plus?
Yes.
Can you relate with that standard form?
Mm-hmm.
Okay. And here it is a x minus. So x is what? X is only 1. So can we say that? And there is a y here. So it
Yes.
would be a 3 Cl minus.
Minus one.
So this is how you can relate with this example, right?
Yes.
Okay. So this is how salt usually dissociate into the product. Okay. Now after that, so if I want to find out the solubility product, so it is represented by KSP. This is the solubility product. So here, what is the product here? Can I say A y plus?
Mm-hmm.
And can you see this B x minus? Okay. And can
Yes.
you just see the coefficient here? X and
Mm-hmm.
y. So
Yeah.
that becomes the power. Whatever
Mm-hmm.
they have the coefficient, so that becomes the power if you're trying to find out the KSP. And you have to take the product of them, product of the like these products. Okay. Now I know you are getting confused. So here, first,
Um.
take the product. Actually, there are two terms, product and product. First product meaning is multiplication, and
Yeah.
second product meaning is like
Is that actual?
reactant and
Yeah.
product. Okay, so that's why.
Mm-hmm.
Okay, so here, can I say that a y plus, and what is the coefficient of that? What
That's
is the
gonna be
number
x
of,
and your
yes, so that becomes the
to the
power.
power. Mm-hmm.
Okay, and this is the multiplication, right, product. Now
Yes.
you have to take b, and okay, what is the power of that?
The power of that would be y.
Yep. And what is the charge on that?
The charge of that's gonna be negative.
Yes, x minus. Got it? So this is
Got it.
how we can find out the ksp. It's quite simple. Okay, so here, so finally we have studied like how can we find out that. So it is better to represent, just take it as s. Okay, suppose if I say their solubility is like, suppose s is the molar solubility. Okay, their molarity I am saying, so s is the molar solubility whenever there is a salt. So let's consider s is the molar solubility. So can we say that ksp is equal to s into x, right? And we can
Mm-hmm.
say this is also s, so it become y. Yes or no? Why?
Yes.
Because I have considered that that is what, that is the solubility, that is also solubility, so that's why. Okay, so now it will become what, it will become the sx plus y, isn't it? Okay, this is
Mm-hmm.
the standard form, but when I take the example, then it would be very easy for you. Okay, suppose if I'm saying that, if let's take an example, if you have NaCl, so of course it is going to broken down into it is going to be broken down into Na plus and the Cl minus, right?
Yes.
Okay, so if I want to find out the ksp for that, so can we let's consider it is Na plus and Cl minus, right? So can I consider it as s,
Mm-hmm.
this is the molar solubility, and can I
Yeah.
consider for the Cl also s?
Yes.
Okay, so is there any coefficient here? No,
There's no
only
coefficient.
one.
No.
So
Mm-hmm.
you will say s into s. Okay, so it means the ksp for the NaCl is s square, right?
Mm-hmm.
Okay,
Yes.
suppose in the question if ksp is already given to you, so can we
Yes.
find out the molar solubility? Of course, so that would
Mm-hmm.
be root ksp is equal to s. Got it? Quite simple.
Mm-hmm.
Okay, so now, okay, so that was a very easy example, but now suppose if I say that you have been given AlCl3. Suppose if I give you AlCl3, then what will you say?
Then I'll say that it will be broken out into Al3 plus and 3Cl minus.
Okay, very fine. And it would be 3Cl minus, right? Okay,
Mm-hmm.
so Al for Al3 plus the molar solubility, yes, molar solubility is S. But here,
Yes.
can I say it would be 3S?
Mm-hmm.
Okay, and now if I want to remember, see very carefully. If I want to find out the KSP, so as there is, what is the coefficient as only one? So it is only 1 into, what is this, 3s? So it is
Mm-hmm.
3s, but I told you, you have to take the power also, isn't it? So
Yes.
it is 3s and it is the power also 3. So
Okay.
now that become what, 3 3 is 9 and 9 3 is
Mm-hmm.
27, right? So
Yes.
it would be 27 s 4. Why? Because this is s cube and this is single s1. So power is going to get added. So that's why we are getting 27 raised to power 4.
Mm-hmm.
Is that clear?
It's clear.
So now we, okay. And if I told you you have to find out the solubility, then it would be ksp divided by 27 and that. Okay. So it is your solubility, isn't it?
Mm-hmm.
So this is how we can find out the solubility product. Okay. So now we have one more thing, and that is known as the ionic product. Okay. So ionic product is so actually whenever a question is given to you, so in the question ionic product will be given to you. Okay, and you have to find out the solubility product. So why we are finding out solubility product? Because it will help you to decide your salt is going to get precipitate, or your salt is going to get soluble, or your salt is soluble or not. Okay.
Mm-hmm.
So here is one more concept I'm going to tell you. Suppose, yes, that is what, that is ionic a product. Suppose in any question, ionic product is already given to you. Okay, and now
Mm-hmm.
you are finding out the solubility product. Okay, so if your ionic product is less than the ksp, so now just tell me which is higher, ionic product or solubility product.
Sorry, just give me one sec.
which one
So
is
can you?
which one is higher, ionic product or the solubility product?
Well, obviously the ionic product
uh,
is gonna
so
be less.
yeah, which is higher?
Oh, KSP. I'm saying that the
Yes.
ionic product will be less.
Okay, fine. The solubility product is higher. It means solubility is higher, right? And if the
Yes.
solubility is higher, so it is simple meaning is salt remains soluble. Okay. And when your salt remains soluble, so will there be any precipitate?
Mm-hmm.
No, no. If salt is going to get, see here.
Oh, I'm
Wait,
sorry.
wait a
Did
second.
you?
Wait a second. Wait a second. Here, the salt remains soluble. I just wrote salt, sorry for that. Yeah, so salt remains soluble. Okay, so if your salt is getting dissolved in the solution, so will there be any precipitate?
Yeah. No.
Yes or no?
No. I mean, no.
Very
I
good.
said like no originally. I said like as in like no, it won't be.
Okay, so
Oh,
there is
sorry about
there,
that.
no, no, it's fine. So there is no precipitate. Okay, it means salt remains soluble, and if the salt is soluble, so how it can form the precipitate? Simple. Okay, but now if I say your ionic product is greater than the ksp, it means your solubility product is higher or lesser?
It means the solubility product is gonna be lesser.
Yes, it is indicating here, isn't it? So
Yes.
if KSP is lesser, so what do you think? Salt will be soluble or it will form the precipitate?
It will form precipitate, meaning
Yes.
it'll be
And what
insoluble.
is the meaning of precipitate?
A precipitate usually is
Insoluble salt.
okay.
So whenever there is a chemical reaction and in the product, unsoluble salt is going to get formed. So that is known as a precipitate reaction. Okay, and that substance is known as precipitate, which is insoluble. So we can say that precipitate of salt from solution occur. Okay, very
Mm-hmm.
simple. Okay, sometimes people also ask, so you told us when IP is lesser and KSP is higher, so salt is soluble, fine. And when KSP is lesser, so it is not soluble, right? So if it is
Mm-hmm.
not soluble, means it is going to form a precipitate. But sir, when IP and KSP both are equal, then people also ask the same thing. Yep.
Mm-hmm.
So when IP is completely equal to KSP, then what will happen? So in that case, it is forming a saturated solution. Okay, when no more solid dissolve in the solvent. So its simple meaning is a saturated solution will get formed. Saturated solution. Okay. So
Okay.
here are three phenomena which you need to remember. Okay, it will help you in solving various type of question. Okay,
Okay.
any single doubt here?
No doubt.
Okay, okay. Suppose if I'm giving you a question. Okay, so I'm giving you silver chromate. What is the formula of silver chromate? Any guesses?
It's is it AGC R207?
No. Okay, so
Ah.
that would be silver dichromate, but I am asking silver chromate, so it would be Ag2CrO4. Okay,
Okay.
so that is our silver chromate, and of course, it is going to be broken down into. Can I say it's Ag2? So it
Mm-hmm.
would be 2Ag plus, right?
Yes.
And it is chromate. So chromate ion would be CrO4 2 minus. So this salt is going to be broken down into 2Ag plus and CrO4 2 minus. Now, so can we find out the KSP for that? Of
Yes.
course, we can say that KSP would be like,
It'll be in
yes,
parentheses
Ag2
AG plus and then to the power of two.
yep,
And
So
then for
that would be
the
plus. Yep.
plus, yeah.
And
And for the
into,
polyatomic chromate, it'll just be CrO4 in one, and then you'll have it to the -2 in the
yep,
brackets.
very good. Okay. So this is how, because there is a coefficient 2, so it becomes power as I told you, and
Mhm.
it is coefficient is 1, that's why there's a power 1. Okay, so now I told you in the molar, like if I say solubility molarity in the terms of molar solubility, so can we consider S? So can I say that if I want to take molar solubility, so can I consider 2S,
Yes.
and can I consider that S?
Mhm.
Okay, so can I put it here, 2S here, 2S, and so raised to power 2, because I
Mhm.
told you it is
Yeah.
2s, so you have to write it here, and that power or that coefficient becomes the power into, that is s, so you have to take s, right? So now that become 2 to the 4, and it's a square and it's s, so that's why it become 4s cube, isn't it?
Yep. Mhm.
So your ksp is equal to 4s cube. So can you find out the solubility here?
Mhm.
Yep, very easy.
Yep.
So how can we find out? Suppose if I'm giving you the KSP, the value of KSP if I'm giving to you, so that would become KSP divided by 4, and it's a cube root, right?
Mhm.
Okay, so it would be S.
Yes.
So that is your, yes, molar solubility, isn't it? That is the equation. So if I'm
Mhm.
giving you the value, so of course you can easily find out, right? Because if I give
Mhm.
the value of KSP, then it's a calculative part and we can solve it. Okay.
Okay.
Yes. Now, if I take one more question for that on the solubility. Okay. Suppose if barium chromate is given to you, barium chromate salt. So if I'm taking a barium chromate, so can I say barium chromate formula is BaCrO4, right? So it's a
Yes.
barium BaCrO4. So it is going to be broken down into Ba
Ba 2
plus
plus.
and CrO4 2 minus, right?
Mhm.
So can I say it is also S, and it is
Yes.
also S? This is very simple, right? So
Mhm.
KSP would be S into S, and that becomes
Yes.
S square.
S
That that
squared.
is that is same like NaCl, right? We
Mhm.
also got the same equation for NaCl, because there is no coefficient, and whenever there is no coefficient, that's very good, isn't it?
Mhm.
Okay,
Yes.
but now if I am giving you a ferrous hydroxide, so suppose if I am saying ferrous hydroxide or trioxide, you can say ferrous okay, better to take ferrous hydroxide. Okay,
Okay. So
so
FeOH
yes, FeOH thrice.
H2. Mhm.
Okay, so if you have a FeOH thrice, so it is dissociated into iron has 2 plus,
Fe.
right? Fe2
Yes, it'll
plus,
be 2 plus.
and it is going to 3OH minus, right?
Mhm.
Okay, so
Oh
the,
wait, wait. Quick question. Wouldn't it be Fe3?
no. Here, if you want to find out the oxidation state, then you will get it Fe2 plus. Okay.
Okay.
Okay. Wait a second. Wait a second. Hey, 1 second. Okay, you are right. I'm sorry for that.
No, no,
Because
it's all right.
it's a OH minus, na. So it's a three.
Yes.
So if OH minus, if there is a 3 minus, so it should be 3 plus, of course. Okay. Sorry for that.
No,
Because
it's all right.
Fe has two valences, 2 plus and 3 plus. So I thought
Yeah,
it would
yes,
be
they have both. So
yes.
ferrous
So
and ferrum.
okay, so
Mhm.
very good. So if I want to find out the KSP here, so the general representation would be, can I say that Fe3 plus N2
Mhm.
N2 OH minus,
Yes.
and should I put power also? Of course,
Um.
it has a
Mhm.
coefficient 3. So I have
Yes.
to take power also, that is cube, right? Okay,
Mhm.
so can I consider the molar solubility also?
Yes.
Because I always take that. Okay, so it would be S, and it
S
would
and
be
three
yep,
S
yep.
cubed.
Okay, so here it become S, and that become
Three
3S.
S cubed.
Okay, 3S cube. So here, so can you tell me what
It'll
would I
be
get?
27 S quadrupled.
Oh, Very right. 27 s raised to power 4, right?
Mm-hmm.
And that would be ksp. So if okay, so if values are given to you, you can easily find out the solubility or ksp, right? Suppose if I'm
Yes.
giving you the solubility, then you can find out ksp, and if I'm giving the ksp, then you can easily find out the s, right, which is the molar solubility.
Mm-hmm.
Quite easy.
Yep.
Okay, and the last one, you have to do it for me. Okay, suppose if I'm giving you lead chloride, so lead chloride is pbcl2, isn't it? So
Mm-hmm.
PbCl2 is going to be broken down into, can you tell me that?
It'll be broken down into Pb2 plus and Cl and 2Cl minus.
Yep, very right. So it will be Pb 2 plus, and it will be 2Cl minus. Find that. Okay, so can we find out the Ksp for that? So Ksp
Mm-hmm.
would be Pb 2 plus, and it would be Cl minus whole square, isn't it? Okay,
Yes.
so now if you want to take solubility, so here, like this is the general representation, isn't it? But now if you want to represent it in the form of molar solubility, then I
Mm-hmm.
told you you have to take s, right? So this is
Yes.
s, and that would
And
be
2s.
2s. Okay, so now it would become uh,
S and then also 2s squared.
very right. So that will be 2s square. So total it will become,
4s cubed.
yep, cube. Oh yeah, cube. S
Cubed.
a square and s, that become
Yes.
4s
Sorry.
cube. Yeah, find that. KSP is equal to 4s cube. So I hope we can solve such type of question very easily, isn't
Mm-hmm.
it?
Yes.
Okay, so after that, yeah. So if you see the next question is given to you
Mm-hmm.
here, the solubility constant of silver chromate, okay, and the silver bromide are, so it means the solubility constant. Solubility constant means, can I say KSP is already given to you? So this is
Yes.
the KSP for Ag2CrO4, and this is the KSP for AgBr, right? And now they are saying that calculate the ratio of their molarities of saturated solution. I already told you molarity means what? Can I say they are asking for S,
Mm-hmm.
molar solubility? Okay.
Yes.
So now let's talk about the first Ag2 CrO4. So if I take first Ag2 CrO4, so it is going to dissociate it like, can I
Into
say that?
Ag2. Yeah, it'll be dissociated into Ag2 plus, and alongside that CrO4 2 minus.
Yep. 2 minus or
2.
only minus? Because
Minus.
wait a second, one second. Something is there. If there's a AG2, it is AG2 now. So okay, my bad. I guess I did some mistake here. Why? Because it is AG2 now. So if it is
Yeah.
AG2, so 2 should be that side.
Mm-hmm.
Okay, very good. So 2, because it is AG2, so 2 should be that side, and that would become a CrO4. 1 second, that is 2 plus Ag2 plus, and that become CrO4 2. 1 second here.
It'll
Here,
be two. It'll be 2 Ag plus, like you
yep,
said, and then CrO4
2
minus
minus, 2 minus, na?
2. Yeah.
So that's why
Mm-hmm.
the because charge always remain the constant. So if it
Yes.
is 2 Ag plus, so definitely it is 2 CrO4 2 minus. This is how we can also calculate our, I mean, we can identify our mistake. Okay, so now what is the KSP for that? So we can say that, okay, it would be 2s, and that
Mm-hmm.
would be s. So how can we find out the KSP for that? Can I say 2s whole square
Mm-hmm.
into only s, because there is no coefficient? So that would become 2 to the 4, and s square and s, so that become s cube, right?
Mm-hmm.
Okay, so and KSP is already given to us, 1.1 into
Yes.
10 to the power 12. So we
Mm-hmm.
can say 1.1 into 10 to the power 12, and oh sorry, so it's 12, right? Is
Yeah, it's
equal
12.
to, and divided by 4, and that
4.
become s cube, right? So
Mm-hmm.
if I take the cube root of that, so I would get the s, isn't it? So right now
Mm-hmm.
I have the calculator. So if I want to find out the value with the help of calculator here, so I am getting 1.1 into 10 to the power minus 12 divided by 4, and then I'm taking the cube root of that. So it is going to to be,
6.5.
yes, 6.5 into 10 to the power minus 5 molar.
Yes.
So 6.5 into 10 to the power 5 molar. Okay, very good. Very nice calculation you have. I mean, you can easily solve such type of values. Okay,
Mm-hmm.
so now that is a silver. That is basically for a silver chromate.
For chromate.
But now, if I want to find out for AGBR, and KSP is already given to you.
Mm-hmm.
So now, if I want to, so finally we have find out the S here, right? Now,
Mm-hmm.
if I want to find out AGBR, so
Yes.
AGBR is going to give rise AG plus and Br minus, right?
Mm-hmm.
So
Yes.
it would be S and that would be also S, isn't it?
Mm-hmm.
So can we
Yes.
say that KSP would be equal to S into S, that would be S square?
Yes.
Okay. Okay, that is a S, so can I take it as S dash so that we won't get confused?
Mm-hmm.
Okay, so that would be S dash because it is basically for AGBR. So now we are going to get under root of KSP is equal to S dash, right?
Yes.
Okay, and what is the value of that AGBR? I guess you have noted that.
Yes. It's 7.07 times 10
Okay,
key power 7.
okay. You are also saying key.
Yeah.
Okay, that is actually Indian word. 10 key power. Okay, good. So 5 into 10 key power 13. Never tell this in your US school, okay? Okay, so that would be S dash. Okay, so what is the square root of that?
Did
It
you get
would be
7.07?
yes, it would be
Mm-hmm.
7.07 into 10 to the power minus 7, right?
Mm-hmm.
Okay, so we are getting the solubility of that, and we are getting the solubility of AGBR. And in the question, I guess they were asking about the ratio,
Mm-hmm.
isn't it? So how
Yes.
can we find out ratio? Ratio is very simple. S upon S dash. Some people are saying,
Mm-hmm.
"Oh, we have find out S and S dash, but I don't know how to take ratio." So a ratio means simple. You have to divide that, right?
Yep.
Okay, so it would be 6.5 into 10 to the power minus 5 and divided by 7.07 into 10 to the power minus 7, and that would be, okay, 10 minus 5 and 10 minus 5. It is going to get easily cut it down.
Mm-hmm.
So I'm getting around, okay, 6.5 divided by 70, 1 second, 1 second. It is 10 to the power minus 7. So it would be 91.9, right?
91.96. Yes.
Yes, so very good. Okay, so you are doing calculation by calculator or by your mind?
Of course, by calculator. How can I do it by my
Okay,
mind?
okay. I'm amazed. Like you are solving it by your mind. It's very fast. Okay, okay, fine that. So I think this is quite easy, right?
Mm-hmm.
Okay. After that, if you do it by your mind, then definitely I will send my children to US. Okay. So after that, but I don't have children. I am unmarried. Okay. Okay, so after that, suppose if I'm taking one more example for that. Okay, just give me 1 second. uh, so now we have the next question, and this question is saying that equal volumes of 0.02 molar solution of sodium iodide and cupric chloride are mixed together. So both are getting mixed together. Now it is saying that will it lead to precipitation of copper iodide? Okay, an ionic product is given to you. So if
Mm-hmm.
ionic product is given to you, then you have to find out KSP. I told you now. So I
Mm-hmm.
told you that formula. Like if there is a precipitation, then IP should be greater, right?
Yes.
And if it want to get soluble, then KSP should be greater,
Mm-hmm.
isn't it? Okay.
Yep.
So there are two kind of salt: sodium iodide and cupric chloride. So if I talk about sodium iodide, what is the formula for that? So it is NiO3. NaIO3. So it is going to be broken down like Na plus. Oh, sorry for that. Yeah, Na plus and IO3
Mm-hmm.
minus.
Yes.
So we can simply say that, okay, so here what is the molarity for that? Okay, equal volume they are saying. So equal
Equal.
volume they are saying, so it means you have to divide by 2 because equal
Yes.
volume, so it means 0.001.
Mm-hmm.
So can I say that if it is 0.001 molar, then it is also dividing equally?
Mm-hmm.
It is 0.01 molar of Na, and that is 0.001 of IO3, because both are getting mixed and it is becoming total 0.01. Na? You don't
Mm-hmm.
need to divide here. Suppose if I'm saying AB is 5, so you don't need to say A is 2.5 and B is 2.5. No. If it is 5 total, then A is also 5 and B is also 5. And
Mm-hmm.
when they are combined, then it becomes total 5.
Yes.
So don't
Mm-hmm.
get confused in that.
I
Okay.
know.
So if it is
Mm-hmm.
0.001, it means I can say that here IO3. So IO3 is what? 0.001 molar, right
Mm-hmm.
here. Okay.
Yes.
And now if I talk about say copper chlorate, so copper chlorate would be oh sorry, I just said copper chlorate is not a
It's
just
copper chlorate. So it's CuClO3 in parentheses with the 2 on the outside.
CuClO3, so that means it would be Cu2 plus, right? And
Wait, would there be a 2 on the outside because it's cupric, I
okay,
think.
so you are saying Cu plus or Cu2 plus?
Oh, sorry. Never mind. No, you're right. You're right.
Cu2 plus, and that would be Cl. Wait a second, I guess I'm doing some. No, no, no. That would be ClO. It's a CuClO3 twice.
Mm-hmm.
Okay, because copper has a valency of 2, so that's why.
Yes.
So it would be Cu2 plus and 2Cl O3 minus, right? So that
Mm-hmm.
becomes equal 2 plus and 2 minus because 2 is ahead here.
Mm-hmm.
So
Yes.
it would be S and it would, oh, there is no need to S here because I'm going to find out for the, we have to find out copper iodide. So
Yes.
copper from here and iodide from here.
Mm-hmm.
So here I'm getting also 0.001. Okay. So now, okay, what is the molar concentration of iodide here?
It's 0.01.
0.001. And that
Mm-hmm.
is a copper that is also 0.001 because it was also the same 0.001, right?
Mm-hmm.
So now, and we have to find out copper iodide. So copper iodide means, can you just see that? Copper iodide is going,
Yes.
so here I can say that for copper iodide formula is CuIO3 twice, right?
Mm-hmm.
So that would be Cu2 plus and that would be 2IO3 minus. So for KSP, yes, can we find out KSP for that? Very
Mm-hmm.
simple it is. So can I say that would be S and that would be 2S?
Yes.
And S is already given to you. This is molarity, which is solubility. This is also
Mm-hmm.
molarity, which is solubility, right? So
Yes.
we can say that what is the copper? Copper is 0.001. So
Mm-hmm.
0.001. Okay. And for IO3, that is 0.001. But that would be 2, right?
Yes.
So if that
Mm-hmm.
would be 2, so it will
That's
become,
0.002.
yep. So that would be 2 into 0.001 and
And that's
to
squared.
the raised to power 2, right?
Mm-hmm. So
Okay.
then wouldn't it be 0, so then basically wouldn't it be 2 times 10 key power
Okay,
minus
if you
6?
have the calculator, can you tell me the total value?
I think so. I think it's not 10, sorry, 4 I meant to say. Not 2, I meant to
Yeah,
say
yeah,
4.
sure, sure.
Sir, give me one quick second.
Yeah, sure. I'm waiting for that.
Mm-hmm. Oh yeah, so it's 4 times 10 key power minus 6.
4 into
Um 10 key power minus 6.
10 to the power minus 6. Okay. And that's it, right?
Yes.
Okay. So KSP is 4 into 10 to the power minus 6. And in the question, what was
Oh no
the,
no no no. Oh, that's not the full thing. That's just for the 2 IO3. But for the full it's just give me one quick second.
yeah, okay. I'm deleting
Then
that.
it'll be sorry, then it'll be 4 times 10 key power minus 9.
Okay, 4 into 10 to the power minus 9.
Mm-hmm.
Okay, that is the calculative
Full, yes.
answer. Okay, so that is the KSP, right? 4 into 10 k
Mm-hmm.
minus 9. And what was the IEP? I mean, ionic product in the question? 6.5 into 10 k minus 5, right? So which is
Mm-hmm.
greater? IP? Oh, sorry, that is not IP.
That's
IP is what? Where is it?
I think what you have to
Oh,
you went up a little bit. You have to scroll
sorry.
down.
Okay, okay.
Um, so it's
Yes.
7.4
Yeah.
times 10 to the power minus 8. So
Okay.
that means that the ionic product is greater than the
Yep. Okay.
H
So if
product.
any product is greater and KSP is lesser, so it means it is going to get form precipitate, or it is soluble.
It's going to form a precipitate.
Yeah. Why? Because ionic product is greater, and if the ionic product is greater, then of course it is going to form insoluble salt. Okay,
Mm-hmm.
so here I guess it's quite easy. So like, see what we are doing in this question. They have intentionally given us NiO3 and the copper chlorate, and with that I have find out iodide from here and copper from here, right?
Mm-hmm.
They can also say that you have to find it for the sodium chlorate. Then I will find out the in that case I have to find out the Na from there and ClO3 from there, right? If
Right?
they ask for the sodium chlorate. Okay, so any doubt in this?
No doubt.
Okay, so it means after June you would be in 11th class, right? 11th grade.
Yes.
Okay, so your new session will begin from July or August?
My new session,
I mean
as
your
in
11th grade.
11th. Usually in the American system, if it may be the same for you guys, what happens is we get off near the end of June, maybe the week or two that precedes July, so maybe in somewhere in the 20th of June. So from either June 20th to June 29th, we get off during that week. We have about 2.5 months worth of summer vacation, as they call it, and we come back on September 4th. But the thing is, for the reopening of the U.S. states, um, a state like, for example, Kansas said they were going to consider opening schools early, but what they considered to be early was September. So it may open actually later, maybe either late September or even early October.
Okay. Okay, so do you have any option for choosing the stream, or like there is only one stream for everyone? Like in India, you know that in the 11th grade, people have to choose a stream like science stream, commerce stream, or art stream. So is this same in US or it's a different?
Choosing courses, yes, it's the same. It's different because actually we can choose a variety of courses. Because usually,
Okay.
what would happen is usually in our course from um ninth
Okay, so
standard
you
to
people are going to choose subjects, right? Not the stream.
subjects, yes.
Okay, okay.
Mm-hmm.
So
Yeah, yes,
have you planned for choosing kind of subject?
yes. I've already chosen. So normally, what would happen is most like the normal trend is that for class 9 you would take
Hmm.
living environment, otherwise known as just biology.
Hmm.
Class 10, which I'm in right now, you would take chemistry,
Hmm.
and class 11 normally you would take physics.
Okay, so
But
in the next session, you are going to study physics.
actually, I'm not actually, because
Oh,
it's not actually regular physics. It's advanced placement physics. Think of it as like a college level physics. It
oh,
goes from
okay.
think of it like for class 9, normal biology, class 10, normal chemistry, but for
Okay,
class 11, college level physics. So I'm not taking
okay,
college level physics in 11th grade. What I'm taking is college level chemistry.
okay. So you are planning to take chemistry.
Yes.
Okay. You like chemistry, like if you compare with the physics or biology?
Mm-hmm. Yes.
Okay, okay, that's good. But you want to be a doctor in future, so why not biology?
I will choose biology, but I'll do that in class 12. But for class 11, I'm choosing chemistry.
Okay, so for class 11th, you are going to choose of chemistry, and when you come in 12th, then you will choose biology, right?
Mm-hmm. College level biology.
Okay, okay, that's great. So it means you are not going to choose physics.
Yeah.
Okay, okay, fine that. Okay, so we'll meet you in the next class, and take
Mm-hmm.
care. Okay,
Got it.
okay,
Thank
bye.
you.
Take care.
Bye. Take care.
Okay.